morning. Yes? So I hope you all enjoyed the keynote this morning. Lots of announcements and demos. So it's nice to follow right after the keynote and hopefully give you all a nice presentation about how to get easy and affordable access to GPUs, which is something that we're all struggling with in the industry right now. And we have a few solutions that are going to help you today. So first of all, I'm Ari Liberman. I am the lead product manager for consumption products of compute. I lead the area where essentially that provides you all the different ways that you can buy and consume compute capacity in the cloud, from commodities discounts, spot, on-demand VMs, and also Google Batch, our fully managed HPC scheduler. With me here today is Ionita, the lead product manager for Dynamic Workload Scheduler. You might have seen it in the keynote this morning. And we're going to give you a deep dive in this topic about how these new consumption models help you get access to GPUs. So let's look at the agenda for today. In this session, we'll cover a few topics. First of all, how Google's infrastructure helps you solve AI and ML workload needs. We're also going to talk about the consumption models that we offer in compute. And then we're introducing new consumption models that are tailored for AI workloads. These are powered by Dynamic Workload Scheduler. And we have two modes, Flex Start mode and Calendar mode. So just to step back a little bit, when we first launched GCE in 2012, we started with a single VM family, N1. Little known fact is that N1 stands for Intel, but today we offer over a dozen different hardware types from Intel, AMD, ARM, and also we offer a lot of compute optimized, memory optimized, and even workload optimized hardware options from partners like NVIDIA, and even our purpose-built cloud TPUs for AI and ML. And let me tell you why it's important to have infrastructure that's optimized for AI. So you've all seen, I think this week is going to be all about generative AI and how models like Gemini, these models are incredibly complex. They feature hundreds of billions or even trillions of parameters. And they put massive demands on infrastructure. Some of these large language models or image models can take weeks and even months to train. So some of our customers on GCP are using thousands of GPUs and thousands of chips on TPUs to train these models. And many of you here today are starting to use some of these foundational models and bringing your own data and fine-tuning these models with it. So you don't have to, go to thousands of GPUs. You can start from a good starting point, like using a foundational model and expanding it with your own data. So let's talk a little bit about what are the different hardware types that support models like Gemini. So we offer a broad range of AI-optimized accelerators, so including both GPUs and TPUs. We've had a long partnership with NVIDIA that started in 2017 when we first launched K80, which was based on the Kepler architecture. Today, we offer up to 6 or 7 generations of GPUs, including Ampere A100s, H100s, based on Hopper architecture. And this morning, you saw our announcement on Blackwell, which is going to be the next generation GPU platform, which is going to be available sometime next year. We also offer cloud TPUs, and TPUs were designed and built at Google to support some of the largest services in the world, including search and Gmail. And this is due to the exponential growth of ML. But with the demand for these models as they were getting bigger and bigger, Google also designed pods. So essentially, supercomputers that are interconnected with low latency networks or interconnects that scale to thousands of chips. So up to 9,000 chips in the latest version, the B5P. And they deliver exaflops of computing performance. Now we're going to talk about how these different consumption models that we offer are available with these different accelerators. So we offer 3 main consumption models that many of you are familiar with: on-demand, commodities discounts, and spot. On-demand is the original consumption model in the cloud. It's what made cloud what it is. You pay as you go. There's no commitments required. You pay by the second. We also offer up to 65% off for 3-year commitments. These are called commodities discounts. And we have 2 flavors of CUDs available today: standard or resource-based commitments, which are tied to a specific VM family, and a region. Or we also offer flexible committed use discounts, which you can use in any region, and these are spend-based, so you can take them to any region or any VM family. And in addition, we also support spot VMs, where you can get access to our excess capacity, essentially, with up to 91% off compared to on-demand prices. These are a great fit for fault-tolerant workloads. So we've seen a lot of success of spot VMs being used for serving online inference. For example, if you have a stable diffusion model or even a large language model, which you're serving to your users, and because of the savings, you can essentially scale and reach more of your customers. So these different models offer you quite a bit of flexibility, and you can combine them together. But they were not designed for AI. These models were designed for mostly steady-state consumption, for app serving or web serving, and to some extent for high-throughput jobs, for batch jobs, but not really for the demanding needs for AI workloads. So now we had to rethink how we could apply new consumption models to apply for AI. And we looked at it from the bottom up. It's not just about the chips. We rebuilt every aspect of the data center, from how you prepare the data, how the storage is located, the networking or the interconnect, for example, in the TPU pods, to how you schedule the capacity all at once, and then also understanding time, so you know how to place different workloads or jobs. Also, we had to think of new methods and primitives that we had to expose from Compute Engine all the way up across the infrastructure on Kubernetes Engine, Vertex AI, Google Batch, and also to our partners, which can access these APIs. And all of this is to give you greater flexibility. And given the unprecedented demand that we're seeing for accelerators, we also had to find new ways to make more capacity available to you. And this is not slowing down. Our customers tell us that timely access to capacity is incredibly important. I met with an infrastructure lead from a nonprofit AI research company, and he shared that they struggle to get even a handful of machines for a few hours. So it's a big problem across the industry, and that's why we're here today in this session. I think, let alone for 1,000 GPUs that you need to do a longer training run. So, and you could look at other alternatives like deploying GPUs on-prem, but when I talked to NVIDIA, they said it takes up to 12 months to get capacity. And these machines can be also very expensive to run. So the traditional methods to scale up capacity using autoscaler and retrying are not effective for AI. So for this reason, we've created a new set of consumption models, and Laura is here to tell you all about it. Please welcome Laura Ionita.
Thank you, Ari. I'm Laura Ionita, and I'm the lead product manager for Dynamic Workload Scheduler. I'm super excited to be here to introduce you to DWS and how it can help you focus less on finding capacity and more on building your next AI applications. With Dynamic Workload Scheduler, we're introducing new ways to consume AI infrastructure, and we're going to be talking about it today. Before we dive into how it works, I want to spend a little bit of time on orienting you on what is Dynamic Workload Scheduler. The DWS core attributes are simple, flexible, and integrated with existing GCP services. Simple, because DWS offers a consistent interface to request GPUs when you need them. And setting up and monitoring your infrastructure remains familiar and consistent. Flexible. We all love commitments. They're great. But sometimes you need to burst beyond the baseline. Your teams need to train a new model. No problem. DWS will give you 2 new ways to get hundreds of GPUs for your workloads. And integrated, because it works out of the box with the main platforms that we offer at GCP that are favored by AI and ML practitioners. It works in GCE. It works if you're using GKE. It works with Vertex AI, and it works with Google Batch. Let's dig a little bit deeper on the new consumption modes. As Ari mentioned, we introduced 2 new modes. They balance cost savings with resource obtainability. Flex Start mode is about getting resources just in time as your jobs are ready to run. DWS intelligently queues your workloads and allocates capacity to them as the resources become available. You can think of this as your everyday operating mode, or like jumping on a wait list at your favorite Sunday brunch place. It's ideal for model training, fine-tuning, or batch inference jobs where some delay is acceptable. Now, let's say your teams have an important deadline. They're looking to wrap up a longer training run, and you need start time assurance. In that case, calendar mode will be the best way to reserve capacity and have a precise start time. With calendar mode, we actually extended our future reservations API in order to provide a quick way to check if there is capacity available and book it for a short duration of time. Think of it like a hotel reservation. It is perfect for time-sensitive workloads, training, experimentation, or just a very long workload that needs to run without interruption. Now let's go and see what these 2 modes have in common. Both DWS modes offer improved access to AI and ML resources. Both help your teams burst up to hundreds of GPUs to start your workloads quicker and run faster than ever before. Your teams will focus less on getting the resources and focus more on getting the results on their experiments and their training runs. Both help you get your accelerators simultaneously. Gone are the days when you would wait for resources. You would start paying for one VM and the second VM and the third VM by the time you actually reach the capacity you needed. And because accelerators are expensive, this new mode allows you to actually save a lot of money because you don't have to hold on to idle resources anymore. You're not waiting for the workloads to acquire capacity. And at the end, when you finish the workload, you can release the capacity because you're confident that you will find capacity again when you need it next time. OK, let's go and see how these 2 modes operate. We'll talk about Flex Start. I'll cover what it is, how it works. We'll do a quick demo, and then we'll talk about calendar mode. OK, so like I said, Flex Start mode is really just-in-time capacity for defined duration jobs. Let's say your team has found a really cool open source ML model, and you need, let's say, 4 VMs or 32 GPUs for a couple of days to fine-tune it on your data. You could go write a script and try to grab 1 VM at a time, or maybe use GKE to scale up, and you may find some capacity, but it may take a few hours to get all 4 VMs provisioned. Instead, with Flex Start, you submit a capacity request where you declare how many GPUs you need, how many VMs you need, and how long you're going to use them for, and then we persist that request until the capacity becomes available. The scheduler makes capacity allocation decisions based on quantity and duration indicated. As a result, now you're going to get the GPUs all at once and run uninterrupted for the entire duration requested. And once you terminate the VMs, you also stop paying, which is pretty cool, I'd say. Let's now talk about how we've improved obtainability. Why is this going to work much better than a traditional on-demand model? Obtainability is a function of 2 variables: how the demand presents itself and what supply we can make available to each request. On the demand side, we actually took a pretty cool feature, which is an Alphabet ML scheduler that we've been running internally with millions of jobs that we provision, deprovision, reprovision, and we brought that amazing technology into GCE. It's a proven scheduler that has a lot of pretty cool scheduling functionality that we are bringing now to GCE customers. And the demand that DWS handles is basically defined duration batch jobs. All accelerators come up together and get deprovisioned all at once, which means that this ensures that everyone gets better obtainability. And with better obtainability, you have a higher confidence to release those GPUs when you don't need them, and that improves access for everyone else. On the supply side, we've done intelligent stuff across multiple pools of capacity that are otherwise not available for indefinite workloads. We actually combine on-demand capacity with DWS dedicated pools and expand across limited duration pools for unparalleled obtainability. As such, our wait times for many GPU types, even the most popular ones, are in the order of minutes. So it's really like running on demand capacity almost. And you'll see it in my demo in a couple of minutes. Okay, don't take my word for it. I'll actually mention one of our customers in the next slide. I'll talk about 2 Sigma. 2 Sigma is a New York-based hedge fund that's using a variety of technology methods, including AI, ML, and distributed computing, for its trading strategies. Alex from 2 Sigma, who's sitting in the room, was one of our early adopters in DWS. When he came to us, he said, I have quota, but I can't get GPUs on demand. I don't find them. When he started working with us, with our team, he was able to integrate their internal scheduler with DWS-enabled APIs in less than 2 weeks. And as such, his teams gained access to hundreds of GPUs for hundreds of internal jobs. They've observed an increase in obtainability by 80%, and they saved months of development thanks to the integrated experience that DWS comes through. Specifically, they used GKE in their example. And actually, if you want to learn more, Alex has a session later today at 4:15 where he's going to speak a lot more about how they went about integrating with our GKE-enabled APIs, or DWS-enabled APIs in GKE. So please check that one out. Okay, demo time. Okay, so for today, my demo has 2 parts. I'm going to show you how we use DWS in GCE, and then I'm going to switch to Vertex AI. For more details on GKE, please check out Alex's session. So if you're a customer who likes to spin up your own VMs, you're okay managing your own infrastructure, we offer today a new API in GCE as part of our managed instance groups, and the API is called resize request. So here I am in Compute Engine. I'll head to instance groups. And for the purpose of this demo, I've already created a managed instance group that has a few instances that are running in it, just to show you how they look like when they're fully spun up. But I'll go and recreate new resources so you can actually see this, how it goes step by step. In this specific example, I've actually created 2 resize requests before this demo. One that was for 2 VMs, 2 A3 VMs for 7 days, and another one that I did this morning just to see that everything works properly. That's just for 1 day. So you can actually combine multiple VMs within the same MIG as long as they follow the same properties. Those properties get defined in the instance template that has been predefined for the MIG. Okay, let's now say I need more VMs. I'm going to add, let's say, 1 more or 2 more instances. And now I'm going to tell the MIG, I'm going to tell in the resize request API how long I'm going to be holding on to those resources. So in my case, let's say I need it for another day. I need 1 VM or 2 VMs for another day. I create the resize request. And now we're going to start seeing, an updated list of resize requests in the background, and already new VM placeholders popping up in my MIG. So this one has changed status to creating. The other 2 are already succeeded. So I can let the MIG do the job from here. I'm running in production right now. I don't have any special rights, so we'll see what the obtainability is. Typically, we've seen that for A3 VMs, it has been really, really quick. And we can come back to this in a second to see how the VM provisioning is going. But I'm expecting that this will be up and running in a couple of minutes. OK, let's switch to Vertex. Let's see. So I'm going to be using some of the new Vertex services. If you've tried Vertex before, you know that it's offering a lot of different options to train, experiment, retrain, fine-tune, run batch inference, online inference. There are lots of ways to use our Vertex platform. We've integrated DWS with the training APIs for Vertex, specifically because that's where there was the biggest need for our customers to find GPUs. So I'm going to be training a new model. Typically, if you're doing experiments, you can do that in a notebook. That works. You're going to click a few buttons, and you're going to go through it. But if you're going to retrain a model, it's actually a lot easier to package it all up in a container, potentially, and then in a Docker container, and run it through Vertex. Vertex is going to do that work for you. So here I have, also for the sake of the example, I see past jobs that I've trained, their ID, they've been finished. It was a custom job. I can see the duration and when it was updated. OK, let's train a new model. I'm actually, for this example, I have my own Docker container. So I'm going to go into custom training mode. Let's call this test. And then I'm just going to use my own container. It's coming up. It's coming up. I can now select, obviously, the output in cloud storage to make sure that all my results are being saved. Otherwise, it will just use default settings. Then I can continue. Vertex offers hyperparameter tuning. Let's not worry about it right now. We don't need it for the DWS demo. And now we're going to select our compute resources. We can either use existing set of pre-spun up resources, persistent resources, that you have up and running continuously, or you can use a new worker pool, which is my case today. So I'm going to tell it that I need an A3 VM. This comes with H100 GPUs, and we offer it with a 8 GPU shape. OK, we continue. Vertex offers to create a prediction container for me today. I don't need it. And then I just start training. Where is DWS? It's hidden behind the scenes. We've done the integration for you. You don't have to worry. You don't have to look for it. Now it's hitting all the supply pools that we've been talking about earlier, and my obtainability has gone up tremendously. OK, let's check out what's going on in Compute Engine. Did I get my VMs? If they're not there yet, we will come back at the end of the session. But I think all my VMs are there. So that's it. I just got 2 VMs, 16 GPUs are attached to it that are running in parallel with everything else I've just created. I have a creation time, and I have a termination time that I know exactly how long that capacity is available for me. And I will not be preempted because these are standard VMs running uninterrupted. OK, so I'll switch back to the presentation. We'll show calendar mode, and at the end, we'll take questions. I saw your hand. OK, back to my clicker. Cool. If you want to get into the nitty-gritty details, we have gcloud commands here for those who are motivated. We have an API. We've seen the UI. Today, DWS, as I mentioned, is available in GCE and GKE in public preview. So you can access it directly whenever the session is over or if you have your laptops up. And in Vertex and Google Batch in private preview. And just with a few changes to your workflows, you can unlock the obtainability power of DWS. You have seen the MIG workflow. I simply had an instance template created. I launched a new MIG. And then I've just launched a number of resize requests that allowed me to get the capacity I needed. The only thing I needed to give it was the count and the run duration for those VMs. Similarly for GKE, similar workflow, you can create or update your node pools to add the option enabled queued provisioning. That is the name of the new API. You need to run version 128 or higher, and that will trigger automatically provisioning requests. From there onwards, you can use queue, which is our GKE job scheduler, or your internal batch scheduling tools or platforms. Okay, are you ready to switch gears to calendar mode? Okay, so in this section, we will cover what is calendar mode, what use cases is designed to serve, how to use it, and how it can save you money. Calendar mode offers a simple way to buy a short-term reservation for ML optimized capacity. This option is great when you need that guaranteed start time. You know exactly when you want to train, and you need to know that you will have that capacity on that day. We've just launched in private preview on April 1st, and we offer H100s that are co-located in the same superblock for the highest networking throughput. We have started onboarding customers who need reservations up to 14 days and up to 128 GPUs. The capacity can be used directly in GCE or with GKE node pools. And since this is a private preview feature, we welcome your feedback, and we really want to know how we can improve this to develop a product that meets your needs. So come talk to us. Okay, let's take a quick look at the use cases. We've designed it, obviously, with training in mind. We wanted to make sure that you have a good amount of capacity you can book, and you can get access to hundreds of GPUs simultaneously. But let's say you have regular fine-tuning jobs. You just want to refresh a model, and you don't need that many GPUs. That's OK. You can also create smaller bookings as many times as you need them. You can think of this mode also for your product launches. So let's say you know you're going to need extra capacity because you're launching a new model. You're going to have a lot of real-time usage, a lot of users. And this block of capacity is going to help you sustain the increase in traffic. Also, you can run experiments and tests. You can reserve as little as 1 VM for 1 day. And you can try new parameters or new configurations on our infrastructure. Let's look at the API. There are 2 steps to it. It's going to be fairly simple to use and works reliably. First step, you create a calendar entry. And using the Future Reservations API, you can create a calendar request by simply specifying the VM type, in our case, A3. I think I can use the laser. The start time and the end time. And that's it. You will get a confirmation in a couple of days because that capacity is already set aside for this specific mode. We are not going to, you're going to get that response really, really quick, basically. Good news is that you can actually share it across projects. And you can also create a reservation using an instance template. That's another way to create a reservation. Step 2, as soon as the capacity is available, you can start consuming it by specifically targeting the reservation. And you have a few options. Either create single VMs, either VMs in bulk, either a node pool in GKE, or you can target the reservation with Google Batch. OK, let's see how this option can help you optimize your costs. Today, calendar mode has a variable price that will follow supply and demand. As we have launched on H100s, the calendar resources are priced as an equivalent rate to on-demand. In this example, we look at the annual cost of 1 VM that you're going to book for 1 year and hold on to it. In this situation, you actually can unlock a 30% discount by using or attaching a 1-year CAD to that VM. And this would be the most optimal way to buy a VM if you need it all the time. However, if you need capacity for only 3 weeks or 2 weeks at a time, then calendar mode can help you save money by not paying for resources you're not using. OK, let's wrap up. In the wrap-up, we're going to do a quick summary, and then we're going to give you a few links to a few resources that we think are good to continue the learning journey for new consumption models. So as you've seen, DWS is not a one-size-fits-all solution. It is designed to accommodate training large language models just as effectively as it manages fine-tuning and batch inference tasks or continuous experimentation cycles. It gives you more options for short-term bursts that in the long run will accelerate your development cycles and save you money. Finally, we'll share a few more resources to continue your learning journey, and then we'll move on to take questions. So we've selected a few sessions that we recommend if you want to continue on this specific topic on how to use compute resources for ML jobs. If you cannot make it in person, you can also access the content on demand and after the sessions have ended. Today, we have 2 sessions focused on optimizing performance, cost, and efficiency. And then we also have the 2 Sigma talk at 4:15 with Alex and Dex and Maciek. Finally, we have the spotlight with Mark Lohmeyer, our VP for AI, ML, and compute. And tomorrow, we also have 2 more sessions for learning how to accelerate your AI workloads with TPUs and GPUs. So be sure to check those out too. We value your feedback, so please complete the session survey in the mobile app. And then finally, this is what I'm going to leave you with, which is basically the links to the documentation for each of the public APIs you have seen in this talk. Feel free to scan the codes on your phones. It's basically the MIG resize request, the GKE provisioning request, and the future reservation API that powers DWS calendar mode. Thank you so much for attending this session, and now we'll open up the mic for questions. I think we have runner-ups with mics in the room. Over there. Oh.
Hi. Hello, hello. Okay, all right. So I have a question, like fundamentally speaking, regarding the flex start modes.
Yeah.
Fundamentally speaking, like what's the difference between using the flex start mode versus like writing a bash script that keep pulling like on-demand instances like all the time? It's like the difference being the fact that the user being able to specify how long he or she would need would enable like the scheduler to make better scheduling decisions?
Right. We make scheduling decisions based on not only the quantity that you're looking for, that you're telling us up front, but also the duration. Today in our APIs, even though you set a count number of, let's say, 4 VMs, that information is not necessarily going all the way to the control plane for GCE. So you're going to get your VMs one at a time. So what happens is if there was only capacity for 3 VMs, you're left waiting for the 4th one. You're not going to see that one, or you're going to see a stockout. So instead of having that experience, the scheduler now sees all the capacity, sees all the customers from different APIs in the same queue for the same type of resource, and that's shape-based, zone-based, SSD, no SSD, and so on. And then it starts making capacity allocation decisions based on that duration and quantity that's been requested.
Makes sense.
And the good thing is, if sometimes you can queue as many jobs as you want. The only throttle, let's say, is the quota. We're actually simplifying that quota mechanism. If you're having trouble getting quota, come talk to us at the end of the session. We'll help you out with that. And then if you have, let's say, queued 10 requests for 10 jobs, but you only have quota for 3, you're going to run the first 3, and the moment the quota frees itself up, then the next job will start. You will not lose your place in line. So you can actually submit multiple jobs and wait for that capacity to be found for each one of those jobs.
I see, makes sense. And the duration, I suppose that's like a hard limit, like in the sense that if my job actually takes longer than the duration that's specified, like it will be killed regardless.
Yes, well, yes, we do limit the duration, 1, to make the scheduling decisions, and 2, to make sure that everyone in the queue has a chance to run. You can also checkpoint and have a new capacity request lined up, and you're just going to get a fresh batch of VMs.
Makes sense. And in terms of pricing, like, is the pricing the same as like on demands for?
Yes.
Okay, I see. Makes sense.
Because you're using them really like an on-demand VM.
Sure.
Short duration, you terminate the VM and you stop paying for the VM.
Makes sense. All right, thank you.
I think in terms of pricing, just to add to what Laura said, on Flex Start mode, it's an on-demand instance, you pay the on-demand price. On calendar mode, it's a variable price, so it's going to change based on demand and supply. So it's starting at the on-demand price point, but it might change over time.
Yeah.
Makes sense. Thank you.
There was a question, the gentleman in yellow shirt.
So in the calendar mode, I reserve, but if I didn't use the capacity, is there a charge?
Yes, you're basically reserving the entire duration. You can spin up VMs, spin them down, spin them up again. The entire duration is reserved for you. So that is a full block of capacity that you'll be paying for the entire reservation. Because we don't know if you're not continuing the job or not. If, let's say, you bring down the training run, you want to restart it again in a couple of hours, then the reservation still belongs to you for the entire duration or the number of days you've reserved.
Then what's the, I guess the benefit is the obtainability.
Yes. We have a specific pool of GPUs that are in one super block, so we know they're co-located. This is the fastest networking possible, lowest latency between those GPUs. So you're getting a consistent experience, and you get the assurance of being able to run on the date you needed. Yeah.
On the Vertex AI demo, when you were going through that,
Yep.
was that, you said it was, DWS was already turned on?
Yep.
Okay, so how do we have to go through the G-Cloud alpha in order to get that turned on? I just want to make sure.
Yep. So either talk to me or your account manager will alpha enable your project, and you'll be able to test it immediately.
Yeah, but very soon, sometime later this year, it will be enabled by default, so it's just going to be hidden behind the scenes. And that's the idea, that you don't have to think about DWS. It's sort of powering the scheduling of the capacity.
Yeah.
But you can get also more control if you go to the GC or GK layer. But on the case of Vertex, right now it's in a private preview. So you do need to enable the alpha access.
I want to take a look at the job, if it's already training. I think Vertex sets up the environment for you. It basically spins up the cluster, gets the capacity, and only when everything is ready to run, that's when the training job starts, and that's the only portion that you're paying for is only for the training run. You're not paying for any of the waiting, any of the resource provisioning part. Generally, I've seen that demo takes about like 10 minutes before it kicks in to train. Otherwise, we can bring it up and see where it is. Yeah.
I have a question.
Where am I looking? Okay, there, thank you.
So you mentioned that some of the use cases are for batch inferencing, and at my company we use Dataflow for kind of batch inferencing, and I was just wondering what the roadmap is for bringing some of the DWS scheduling under the hood for Dataflow resources on GPUs as well.
So this is one of the priorities for us from a roadmap perspective. Please come talk to me after the session. I really want to bring in your feedback, as we're prioritizing basically the next set of APIs like Dataproc and Dataflow specifically to integrate with AWS. Yeah. Over there? Oh, here, sorry.
Hi. So you mentioned that, the calendar mode you can share with across the projects, right?
Yes.
Okay, but in the command that I didn't see from which projects you sharing these resources, right? How do we specify that projects?
I'll go back. It's basically one of the options here. Oops, sorry. I think I was here.
Oh, okay.
Share with, and then you line up, you can include the project names or numbers. Numbers.
Okay.
Names. Yes.
Would it be applicable for other mode also?
For
flex mode?
No, because right now flex mode, it's only running in each project. And because you have a lot more granularity in flex mode, you can select less VMs. You can run on smaller sizes.
I think that the difference is also that on flex mode, you're getting the instance directly.
Yeah.
So it's sort of like, G-Cloud create instances, and you're getting the VM. In this case, in calendar mode, you're getting a reservation. So the reservation can be shared across multiple projects, and then you can target those reservations within your projects. That gives you more flexibility if you have multiple teams kind of like using that capacity. Let's say you got 100 GPUs for a couple weeks. You can also you can share it more effectively. But with the case of FlexStart, it's more for your day-to-day operations. You just spin up the VMs. When you're done, you spin them down. You don't have to pay for it after you're done.